All right, this video is about simplifying monomials, especially talking about properties of exponents. So in the first paragraph here, it talks about to simplify an expression containing powers means to rewrite the expression, and here's the key, without parentheses or negative exponents. Negative exponents are a way of expressing the multiplicative inverse of a number, and the following table summarizes the properties of exponents. So let's take a look at this table, this chart of the properties of exponents. So if I can make it a little smaller. There we go. And this is something you're going to have available. You'll get in class. I'll give you a copy of this. But properties of exponents. And there's a bunch of different properties here. So let's go through each one really quickly. Products of powers. Product of powers. Product means multiply, right? Powers. So you're multiplying together. Notice the x's, the bases are the same, and you add the exponents. Then you have a bunch of examples over here of how that, or what that looks like. So product of powers. Then you have a quotient of powers. Quotient means divide. You have the same base, x divided by x. You take their exponents and you would subtract them. So look at the examples that are over here. All right, negative exponents. X to the opposite of a. Whatever a is, x to the opposite of a is the same as the reciprocal. It's a multiplicative inverse. Reciprocal, multiplicative inverse. Good vocabulary from Algebra 1. So if you have the x to the opposite of a in the denominator, it would go in the numerator with just x to the a. So look at the examples. 3 to the negative fifth and 1 over b to the negative seventh would just be b to the seventh. All right, power of a power is just what it says. You have an exponent, you have another exponent. So you have x to the a to the b. You just multiply the two exponents together. Again, look at the examples. Power of a product. So you have something being multiplied in a group, and then you raise it to a power. You actually distribute the exponent to each of the factors in the parentheses, or what's being multiplied there. So x times y, all to the a power. You can do x to the a, y to the a. So again, look at the examples there. A power of a quotient. So you have something being divided. That's in a group. All that's to a power. You can actually break it apart. So the exponent a goes with the numerator of the x. And here the a would go with the denominator, which is the y. Look at the examples. If you have xy to the opposite of a, remember when we talked about a negative exponent up above here, we talked about the reciprocals, the y and the x and the y do the reciprocal y over x to the positive a. So a over b to the negative fifth, it'd just be b over a to the fifth, and b over a to the fifth power is b to the fifth, a to the fifth. And then finally, quick review of zero power. Anything to the zero power is 1. Okay, next thing I wanted to show you. We talked about this a little bit earlier, simplifying monomials. Here is a little chart emphasizing what you need to remember when you simplify monomials. First of all, there are no power of powers. That means you don't want any parentheses involved. Each base appears exactly once. All fractions are in simplest form. And there's no negative exponent. I'll give that a tornado underline. No negative exponents. So this is simplifying monomial. You know it's simplified if, again, there are no powers of powers. Each base, remember there's a base and then the exponent is up to the right of the base. only appears once. All fractions are in simplest form, no negative exponents. Okay, now I want to take you through a couple examples applying those rules. Grab my pen tool. So we're going to simplify each of these expressions. Assume that no variable equals 0. Because if a variable equals 0, just make everything 0 because you're multiplying. All right, so we have example A. I'm multiplying all this together. And you see a bunch of parentheses. And you can break the parentheses. You can actually take them away. It's all multiplication. And you can multiply the 2. I'm not sure why I scratched that out. I wanted to highlight it. Let me grab my highlighter tool here. You can multiply the 2 times the 3, and it'll give you 6. And you have a's. You have a to the negative second, a to the third. When you have the same base, just a reminder, when you have the same base and you're multiplying, that's the product of powers, you actually would add the exponents. So again, you can go back to the chart anytime you need to. I'm not going to keep flipping back now, but you can do that if necessary. So I would take the a's and add negative 2 plus 3 is 1. So it'd be a to the first power. And then I look at the b's. I have b to the second. It's only b to the second I have. And I have c to the negative second. So to finish this, I'd have b to the second, c to the negative second. Now, I don't need an exponent of 1, so I can just write 6 and then just a, because exponent of 1 just means a. And I have b to the second. And to be simplified, remember, I can't have a negative exponent. That would make the c go in the denominator with a positive 2. This would be my final answer to this. All right, in example B, notice I have a quotient, I have a division bar right there. And I have a q to the second, q to the seventh, which means I would just subtract their exponents. 2 by 7 is negative 5. And I get q to the negative fifth. And then I have my r's, r to the fourth, r to the third. I subtract those exponents. It would be r to the first. I cannot have a negative exponent. So q to the negative fifth becomes 1 over q to the fifth. And with the 1 in the numerator would be the r to the first, which is just r. So that would be simplified. All right, example C. I have this quotient, negative 2 times a to the fourth divided by b squared. All that is being raised to the third power. So what I can do here is I can distribute. I have a power of a quotient. I can distribute that like it is here. So negative 2a to the fourth in parentheses to the third power. And when I do that, let me click on my highlighter tool. This right here, I can then raise it to the third power. I would distribute that third power to the negative 2. Negative 2 to the third power, which is right here. Then I have a to the fourth to the third power, right there. Now let's just continue with the numerator. So negative 2 to the third power, that's 3 negative 2's. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. So I get negative 8 here. That would give me negative 8. And a to the fourth to the third power, a power of power, you actually multiply the 4 times the 3 together, you get a to the 12th power. Now for the denominator, the b squared to the third power, it would just give you b, it's a power to a power, so b to the 6th power. So I put that in the denominator, b to the 6th power. And there's no negative exponents. I only have one a and one b. In other words, I don't have b times b. There's only one base of each. And I have a negative 8, so that looks good. That is simplified. So we'll practice that. We're going to go over the rules in class for the exponents. We'll review those from Algebra 1. And then we're going to apply it as we simplify monomials.